Hi, this is Algebra 1, Module 4, Lesson 8. These are the practice problems. Let's look at equivalent equations first. The pairs of equations below are equivalent, so they're saying they are equivalent. Determine what was done to the first equation in order to obtain the second equation. So for example, everything is multiplied by 5, or a multiplicative property of equality. More than one operation was performed. Please indicate the operations and the order they were performed. So if we look at these, we can say, well, how do I go from 1x to 3x, 1y to 3y, 5 to 15? Hopefully you recognize this is a times 3. Everything was multiplied by 3. So it's almost like we had the distributive property around this and did a 3. All right, next one. Here we go from 4x to 1x, so it's getting smaller, 3y to 3/4 y, 12 to 3. So in this case, you would say everything was a divide by 4 or times 1/4. So we could take this top one and divide 4 on that. Okay, or multiply 1/4. All right, this last one. Oh, they rearranged it on us. Let's go ahead and rewrite this so it's a little bit easier to compare. So they have the y by itself, the x over here with the 5. Let's add the 3/2 x to put it over here so then it's set up the same way. So if I add 3/2 x to both sides, I'm going to have 3 positive 3/2 x in parentheses, so I don't think it's 3 over 2x. 3/2 x plus y equals 5. Give myself a little space in here. I don't like to crowd my numbers. Make them a little easier to read. Okay, so I'm going from 6 to 3/2, 4 to 1, 20 to 5. Well, if I divide by 4, 6 over 4 would be, I'm going to go ahead and just write this so I have the visual, 6/4, which would reduce down to 3/2. So it looks like here is another divide by 4, 4 times 1/4. And so first, what we did was technically, go ahead and erase this on the side. We didn't divide first. First, we subtracted the 1/3. So we added 3/2 x to both sides. Then we divided by 4 or times 1/4. So this one was a two-stepper. All right. 4. Determine whether or not the pairs of equations are equivalent. So we don't know. If equivalent, state the operations used to create the second from the first. If not, show why. Okay, well, here is a 54 to a 9. Here is a 42 to a 7. Here's a 90 to a 15. Well, I know that 54 divided by 6 is 9. So this one's a divide by 6. 90 divided by 6 is actually 15. So here's a divide by 6. Here's the problem with this one. If I have a negative 42 divided by 6, I should end up with a negative 7. So these are not equivalent. Equivalent. You know what, I'm going to type this so I can fit everything better. Equivalent because negative 42 divided by 7 is, or 6, divided by 6 equals negative 7, not, let's put 7. All right, So these are not equivalents. We have to be a little picky as we're looking through these. Okay, this next one, going from 12 to 4, 9 to 3, 21 to 7. Okay, so I recognize there is a divide by 3 going across here. Positive to positive, yep. Positive to positive, yep. Positive to positive. All right. So we have a divide by 3 or times 1/3. All right, good. Last one. Oh, they rearranged this for us again, didn't they? Well, let's go ahead and um, maybe this time, let's subtract the 2x so that, eh, no, I want to move this one over. It's easier for me to compare when the x and y are on the same side. So let's go ahead and subtract the 2x, and then we can compare what this looks like. So I'm going to put negative 2/5 x plus y equals 10. Okay, so I have from 2x to negative 2/5 x, 5y to just y, 10 to 10. Well, there's a couple of things that stand out here. Um, if 10 to 10, those are equal, so nothing's happening from 10 to 10. It looks like I'm dividing by 5 for the y's. Also looks like I'm dividing by 5 for the x's. The only problem is this is a negative and this one's a positive. So then I have two different operations. So there's a few things going on here. This one is not equivalent because 2 divide as x's divide by -5. The y divides by +5. And the 10 divides by 1. So we are doing all sorts of different things to get this one. There's not a whole lot that's equivalent about that. Okay, next. Literal equations. Solve each equation below for y. So we're solving for y. That is not usual. Usually we solve for x. So solving for y and put the equation into slope-intercept form. So they're being picky on two things. Show your work and justifications. That's why we're solving for y. We want a y equals for our slope-intercept. So for this, first step, I need to subtract 5. Let's see if I can write small enough for this one. I want to move all of the 5x minus 5x. Those cancel. Y equals, and I want it mx plus b form. So negative 5x plus 12. So I need the x's first. This is a, oh, I just saw a mistake. Undo, undo, undo. Anyone catch that too? Say, wait a minute. Negative 5x opposite is adding 5x. Aha, now they cancel. Y equals 5x plus 12. This is an addition property. That's all we needed for it. Okay, 8 over here. It's purple on this one. All right, first I need to move my x over. So minus 6x this time, because it is a positive, and that was a subtraction property. Leaves me with 2y equals negative 6x plus 12, because I want my x first, so it's in slope-intercept form. Now I need to divide by 2. And when you divide by 2, you have to divide everything by 2. So y equals negative 3x plus 6. That was a division property. Okay, next we have to move our x again. So it's a negative 12. This time we're going to add 12x. Remember, when I want to move the x with it, I have to add or subtract. So that's an addition property. Those cancel. 4y equals 12x minus 16. Yep, just double checking my work here. Now to divide by 4, because I have a minus in there, I have to sub everything by 4. So y equals 3x minus 4. That was a division property. Okay, last one. Positive 5x. So now I need to subtract 5x. Being very careful on those now that I missed that first one. Subtraction property. Those cancel. Negative 2y equals negative 5 plus 10. Remember, those signs go with the number. Divide by negative 2, negative 2, negative 2. Y equals double negative makes a positive, and I'm just going to go 2.5. X. 10 divided by a negative 2 is a negative 5. And that was a division property. Hey, so hopefully you're getting really good at these by now because we've been working on those a lot. All right. This one has a lot of information. I'll have to kind of scroll up and down a little. All right. So the equipment manager for the school athletics department is attempting to restock some of the needed uniform and equipment items for the upcoming seasons of baseball and football. It's been determined based on current levels of inventory and the number of players that will be returning that more socks, pants, and helmets will be needed. So that's what our labels are up here. Equipment manager has organized the information in the matrix. So baseball needs these many pairs of pants, socks, and helmets. Football, this needs this many socks, pants, and helmets. The school has contracted with two supply stores in the past for equipment needs. The matrix below shows how much each store charges for each item. $3.50, $3, 35, 40, 22, 45, 50. So a little bit of a change difference there. We need to use all this information to find a total cost matrix for each of those. So remember when we did this, we had to do, it's like spastic, there we go. Socks times 13 times 350 plus 15 times 350 plus 7 times 22. And that gave me my total cost for baseball. So remember, if I take the top row times the first column, that gets me the top first left, whatever spot over here. So that's how I'm going to set this up. Basically going to, let me go ahead and I'm going to redraw this one down here. Let's do it in black so it matches. I'm going to bring these guys down here so it's easier to see. So we have 13, 15, 7. Then we have 24, 45, nope, and 20. And so let me go ahead and put some labels in here just because we have base. Oh, what am I doing? Here we go. Baseball. And then we have football. Space here. And then we're going to do, this was socks. Oh, that's really big. Let's make sure that font size is correct. Socks, pants, helmet. Okay. A little bit. That's bothered me. Make sure we have, I want to make sure it's easy to read. A little harder since we're doing this on the computer, but we can still manage. Okay, so we're basically going to take these and combine them the way we were talking before. So what I just said on there, um, and actually 12 says show the detailed calculations for finding the values of A and B. So let's actually just show our work down here and we'll kind of do a 2-for-1. So we'll do these in green. So I'm going to take 350. I have 13. Did I type so? Oh, 13. I didn't type that one right. 13. Okay. We'll do blue. We have blue. These guys. All right. So we take 13 times 350. So for A, 13 times 350 plus 15 times 35 plus 7 times 22, right? 7 times 22. And when I add those all up, I end up with 724.50. So that's going to be my first box, 724.50. So that's my first space in here. That's the A. Okay, let's go ahead and do B. And that ends up being, so B then is play it forever. So I'm doing the same three numbers, baseballs, and I'm going to put those in with these three numbers. So I need 13 times 3 this time, 13 times 3 plus 15 times 40 this time, plus 7 times 45, 50. And that's going to equal 957.50. So that's significantly higher, isn't it? So this guy, 957.50. Ah, 957.50. Okay, so now we need to do the same thing for C and D. And you know what? I'm just going to go ahead and show my work down here because that's easier for me to work it out. Um, okay, so C, I need to take 24 times 350. 24 times 350 plus, and now I'm going to take 45 times 35 plus 20 times 22. And I end up with 2099 on that one. So 2090, does it keep changing my stuff? Oh, blue, 2099. Right, just kidding. Didn't listen. Okay. All right, so now let's see what happens when we do the same thing for D. So D equals, now I'm going to take 24 times 3 plus 45 times 40 plus 20 times 45, 50. Those are significantly different costs for those helmets. And that is going to get me $2,087. $2,787. Okay, so when I'm all said and done on this guy, here is her total the total cost matrix. Guess it's not Elvira, it's the manage the sports people now for their work. All right. Phew, another matrix problem. Okay, here's some practice with equations. So a table and equation for the visual pattern to the right. If you're unable to create the equation for the attribute identified, then state the pattern you notice. All right, so everything equals 1. The width of the large triangle, we're going to do text boxes for this. The width of the large triangle with respect to the step number. So step number is this top one, and the below is width. Okay, so I'm just going to do a big line on here. Make these somewhat even. Okay, so when we have step number 1, and then we have step number 2, I need to make these so wide, and then 3, and we'll do 5. Okay, so let's go down here. So the width. The width is 1 when we go across, right? Because step 1, 1 triangle across. Step 2 is 1, 2 triangles across. Okay. Step 3 looks like we have 3 triangles across. I guess we don't need to go too much further. We don't have any more options on there. So I'm going to guess that 4 is 4 across and 5 is going to be 5 across, which means my equation is y equals x, right? Because it doesn't matter what my y is, x is the same. So step number and the width are the same. All right, next, the number of small triangles with side length of 1 in the large triangle. Oh, another number of small triangles with side length of 1 in the large triangle with respect to step numbers. We're not saying like this is a triangle and this is a triangle. They just want us to know 1, 2, 3, 4. Okay, so or are we just doing the dark triangles? Let me see on here. I think we're just doing dark triangles. So with the step number. So step number and triangles. Okay. So one, find a pattern in 3 this time. Okay, so step 1 has 1 dark triangle. Step 2 has 3 dark triangles. Step 3 has 1, 2, 3, 4, 5, 6 dark triangles. Okay, so can we see a pattern? Well, 1 plus 2 is 3. 3 plus 3 is 4. So I'm adding the step number. So really what we have to do in this one is we have to do a recursive. So I need to do f of 1 equals 1. My first one equals 1, but then f of x equals my previous term plus my term number, right? So if this is a 2, then I need to take 1's answer and add 2 to it. 1 answer is add 2. This was 3. I need to take 2's answer plus 3. 3's answer plus 4. So the explanation then is add the step number to the previous, add the step number to the previous answer. Yep. Okay. Perimeter of the large triangle with respect to the step number. So again, we're going to have step number. And I'm going to make this one a little extra straight. Perimeter. Okay, so let's see, we'll do 3. Okay, so the perimeter is 1, 2, 3. Okay, 1, 2, 3, 1, 2, 3, 4, 5, 6. So this one has a perimeter of 6. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one has a perimeter of 9. So it looks to me like get my perimeter to get my y equals 1 times 3, 2 times 3 times 3, x. Multiply by step number by 3. Okay. Number of 60-degree angles in the figure respect of the um, the step number. Okay, that's kind of a different one. 60 degrees. A little bit of a slang on this one because I don't have tons of space. All right, so let's see. Number of 60 degrees. Well, step 1 has 1, 2, 3 60 degrees in there. Number 2 has 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're just focusing on the black triangles. 9. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this one has 18. Okay. So do we see a pattern in here at all? Well, this one's a little bit trickier. Seems like we're kind of tripling. We tripled that. We doubled that. We times 6. That's times 3. Times 3 plus 3. What if we did times 3 and add times 3 and add the previous? The first 0 would be 0, right? Times 3, add 3. Times 3, add 9. Oh, look at this. If we times this one by 3, and then we add the previous answer, times 3, add the previous answer, that's an 18. So that one would have to be a recursive 2 because I don't really know how to write equations for those types of things yet. So I want to do equal. So I want to take the previous answer and add to it 3 times, I put an in there, 3 times the step number, right? So 1 times 3 plus the answer to the previous, which would be 0, 3. 2 times 3 is 6, plus the answer to the previous, which is 3. 6 times plus 3 is 9. 3 times 3 is 9. Add it to the previous, plus 9 is 18. Okay, so that one's a little trickier. So triple the step number, then add the previous answer. All right, last one. Number of white triangles in the large triangle with respect to step number. So again, we're going to have step number white triangles. Maybe I should clarify up above that we used black triangles. We do that. so we're not confused when we get to this. We look back at this later and go, they're all triangles. Why did we get two different answers? Okay, so up here, let me go ahead and get my on here. So right triangles. Well, my first one doesn't have any, so that's a 0. My next one has 1. Okay. My next one has 3. Okay, so what kind of pattern do I see here? Well, +1, +2. This one's probably going to be a +3. So it looks like I'm kind of adding the previous step number, right? One less than the step number. So that's going to have to be, again, a recursive because we don't really know how to do that one. So technically, my first one is 0 this time, right? And if I do f of x equals, I want my last answer, f of x minus 1, and then I want to add 1, let's see, we do our x minus 1, right? Because I'm going to take my previous answer and I want to add the step number behind it. So if I have a 3 here, I want to take the answer to 2, which is 1, and add 2 minus 3 minus 1, which is 2, to get 3. Yep. Okay. So I'll add 1 less than the step number to the previous answer. All right. And that is it for this one. So thank you for joining us, and we'll see you next time.